that I ran my code on the M13 cluster, and all the objects that it found didn't seem to make sense. There were a lot of objects with nothing in the center of them, right? So I'm thinking that the way that my walk image method is storing indices in the image is flipped upside down. So that is yet another bug that I've added to my my list of bugs that I need to look into. Thankfully, I have images that are just a single object, and we're going to briefly look at those. I do not have a ton of time today, guys. We have a fella working his last day with us today, and we are going to do a happy hour with him at the restaurant underneath our office. So I will only be able to hang out with you guys for approximately 45 minutes today, but I wanted to give you an update on what I had found since Wednesday. If DPI is still in the chat, I've been thinking a lot about his idea to use those regions of interest to debug that situation. So what I can do is have it create a region of interest around the image, or not around the image, but around the pixel that the image is working with, and visually troubleshoot what's going on. You know, set breakpoints, because obviously if it just runs, it's going to do all that so fast we can't see what's going on. But set breakpoints so it pauses after it sets that pixel is active over the overlay, and then it'll pause again as it analyzes each pixel around it. I've also discussed with Andreas the concept of enlarging the radius of the pixels around a specific image that are analyzed. Instead of just the 8 pixels around it, why not expand that to 2 or 3 pixels in each direction from the object? That may eliminate some of my woes as well. But I want to show you something kind of entertaining here real quick. One of the simulations that he made for me this morning with just 4 objects in it. The reason I asked him to make me smaller simulations is because my algorithm is finding the same object more than once in some instances, and in my head I know why that is, which is why DPI's idea has been sitting so heavy in my mind. But thankfully, with these smaller images with just 4 objects in them, I think this is the one I wanted. Yeah, this guy's just got 4 objects in the sky there, we see. And that 16 is the appropriate input full width half max. We're just going to leave these multipliers as the defaults. We're going to leave gain as 1, and we're going to change readout noise to 0. Okay, so you can see here already it found 6 objects, right? That's too many. We all saw there were only 4 objects in that image. Let me get it back on the screen here. If I could figure out how to computer, that'd be nice. Here we are. So I think at a glance we can see that it's these top 2 that it found twice, right? Because those lines look a little thicker from a distance. And if we zoom in, we can clearly see 2 sets of circles. We can also clearly see that the 2 object centers are, what, a pixel or 2 apart? Probably one to the left and one to the right. It looks pretty evenly. Let's see if I can get this red circle square in the center. It looks pretty evenly spaced. A pixel or 2 to the right and a pixel or 2 to the left. It crosses it essentially the northern and southern, or the y-axis essentially, right? And I'm guessing, yeah, it looks like the green and the blue are both very similar in where they cross. So I'm guessing it's finding 2 objects side by side, which is concerning, obviously. And then this one's a little more off kilter, right? looks like our circles cross on a tilted axis, right? We've got something a little closer to that 23 degrees of Earth. This is not Earth, by the way. Anyway, let's take a look here at chat and make sure I'm not missing anything. So music is still barely audible even after the update. I'm going to leave it alone because that seems to be what everybody prefers. I think it's more important to hear me than the music. But I like to have something going just for when I'm like focusing and in the zone or Googling something or whatever, right? Just for something entertainment. Oh, is the fan bumping it again? I don't think it is. And by the way, there's no possible way that I can turn these fans off. It is sweltering, and even with the new HVAC system, it's still, once I turn all the lights on, open my window. I actually did turn the cyclone fan behind me off because it's probably the noisiest of the three. My ceiling fan's still going. I've got a little oscillator here next to me over my left shoulder, which in the image sort of looks like my right shoulder because optics and mirroring and all that fun stuff. But anyway, hopefully that's not too disruptive. All right, Phoenix says, yes, sort of, but they did the middle down and then the top half. I am confused as to what you're referring to there. I probably moved on from that thought in my head and just completely lost it. Hanny, to address your surprise there, I'll show you. I will show you briefly. I actually just had it up on the screen here earlier before I started stream. But here, this get objects method is essentially the scan the entire image and build objects method. And so what it does, it just creates an array list that we can store unidentified objects, which is a class that has all kinds of instance variables, but essentially intensity and a set of indexes that are inclusive, ideally, of the object. Obviously, a couple of those objects are getting two different sets of indices or two different sets of pixels. And then what we're looking for here, so it passes a 2D array, which is essentially the image with an intensity in each of these memory addresses. The n sigma is that value that we select 6 times the sigma value, and then the background is, I believe, the average pixel of the image. So it has to be 6 times the average pixel before it determines it's an object. And then the image processor is something I have to pass that has information about the image, like its height and width, I think, are primarily what we use it for in this method. But here you can see, here we're using the image processor right here to get the height and get the width. So I called that one, even though this is one of the very first bits of code I wrote for this, so I'm a little fuzzy on that. But so here it even says scan left, right, top to bottom until we find a pixel n sigma over median, not medium, median. And then if that intensity is greater than n sigma, again, if it's greater than 6 times the background, we have an object or a pixel that belongs to an object. And then I set the UI index to -1 just because indices can't be negative, and if it is, we know it's not been manipulated, right? So here is where it checks to see if the list is empty. If it's empty, there's definitely no other object that this could belong to, so it just straight away creates a new object, adds this pixel to its array of pixels, and then let's see here, we set the unidentified object index to what this find nearby object returns, which, let's see, here that should be, wait a minute, if it is not, oh, this is if it is not empty. In other words, it will find a nearby object and it'll return the index of it from this array, and then it sets the UO index to that. And then here, if the UO index is not equal to -1, meaning if it found an object, then it goes through this. It'll get the index and set the object coordinates of that unidentified object. So it'll set the Y, the X, and then the intensity, because that's what a set object coordinate requires. Now, if here it checks to see if this new pixel has a greater intensity than the pixel, the center intensity of the object. If it is, it updates that. It updates the center of the object here. And then it does the walk image, which scans the 8 pixels around it. Otherwise, it just knows it's a new object, creates a new object, and then does the walk image. And then here, if it is empty, it creates another object as well. Now, the find nearby objects method is what I wanted to show you. Once this find nearby objects, what it does is it takes this pixel that it finds, and it makes sure that it's not within 2 pixels, or within 2 pixels of the same row or same column of an already existing object. So it scans all the let's see, for unidentified object pixel P in the object pixel list. So whatever unidentified object it determines it's near, it pulls that pixel list and then compares to see if it's within 2 pixels of that object. Now, this is very ugly code, as you can see. This conditional statement is a this or this or this or this or this. And this is where it's falling apart. I just am not sure how to improve this. And that's what I was talking to Andreas about increasing that walk image radius from just the 1 area of pixels around it to maybe 2 or 3. But moving on from that, let's see what I missed on in chat while I was yammering. Okay, no, everybody's still just listening. All right, so moving on. I got a new image from Andreas this morning, and it should have, where are we at? Desktop, fits images, tests, and then the noise list. Let's just use this one again. We're going to select 6 standard deviations from the background. Oh, I was like, what are we waiting on? It's waiting on input from me. Okay, so we're going to leave everything alone except that readout noise, which will be 0 instead of 5. Okay, and then we're going to examine the text output. The circles we've already seen, and we're not interested in that, at least not right now. Here we are. Okay, so the 4 objects. Okay, so the output should be 1 times 10 to the 6th power, and what you can see here is I have 1.4 times 10 to the 6th power. So this signal is 40% higher than it should be, which means that my method for determining signal is clearly flawed. The good news is that flux is very, very tiny, and that flux, our goal was to get the flux within less than or equal to 3%, and it's well under 1/10 of 1% at that mark. So the flux is fine, or at least it is for now. That may change once we figure out what the problem is with the signal calculations, which I'm going to take us to right now to try to determine where I might be erroring here, and I'm trying to collapse. I wish it would just do this. Find object. Whoa, 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 whoa. Find objects is the plugin. I can't collapse the whole thing. Main, I cannot collapse. That's the only thing I don't want collapsed. Everything else I need open. Or collapsed, rather. Yeah, there we go. Okay, so signal calculation. What are we doing? Okay, so in here we're determining all those radii on those circles. We're subtracting the inner annulus from the outer annulus to get just the pixels in that ring. Not no flux, but only just a 1/10 of 1% flux. Which, according to my scientists, that is more than adequate. More than adequately accurate is what I'm looking for. So then, once we've determined those, the pixels that are inside of that ring, which is the annulus, and then I believe we calculate a background from those. Let me find that. Okay, so this is where we're taking all our inputs, and here's where we begin doing our calculations. Here. So this is where we build an array of the regions of interest, and we extract the sets of points, if you will, from inside of that. Okay, and that's where we do this, and then this is where we remove the inner annulus points from the outer annulus points to get the ring, and then we do what's called a sigma clip of the annulus, which is removing outliers. And I think what I'm going to do, Andreas gave me some advice, and I'm going to bring him up on Slack here briefly. Let's see here. Okay, so he says that start by not subtracting the sky or setting it to 0. Let's just count how much you get per object. So he wants me to not subtract the background. That's going to make it even brighter because I am subtracting the background. Here, let's see what we're doing here. We're looking for we're trying to set a clipped mode, which we will use we divide the mode of those pixels by the number of pixels to get a background, which for some reason doesn't feel right. I'm starting to think I'm not subtracting enough. And I'm not entirely sure if that background is having the gain applied to it, which is irrelevant for this in particular problem because the gain is 1. It just multiplies everything times 1, which is a meaningless calculation, right? Let's see here. So, set background. Well, let's just try setting background to 0 right now. Okay, and then let's see here. So then we start tabulating a signal. For points in the aperture points, as long as the points x value is not negative, points y value is not negative, x value is not greater than the width, and y value is not greater than the height. And if the gain is not equal to 1, it'll multiply it times the gain. Otherwise, it just sums the intensities of the signals. Alright, and then this is where This is also something I probably need to... Okay. I think that is what Andreas wanted me to do. Let's see what we come up with now. This will also drastically lower our flex because our flex is determined by background as well. But let's see what happens. Let's run it and check it out. Let's see. Let's see. Background is what we are comparing the bright pixels to. No, we're not comparing them to it. We're subtracting the background from it. We assume that brightness that we find out in the outer ring is permeating through our object, so we subtract it from our object, if that makes sense. Let's see. What happened? Why do I not have a... Oh, here we are. Probably because I have too many windows and not enough monitors. Desktop, fits, test, and noiseless. Let's try this beast. Right cheer. 6 standard deviations. We're going to leave everything alone. We're going to leave gain at 1, and we're going to change readout noise to 0. Still found 6 objects, which we haven't changed anything to assume that it wouldn't. So, here's my output. It's just still thinking. And, well, this is interesting. That is exactly the same output that I got before. Weird. Weird. Super weird. Okay, so S, maybe that I didn't save the file first. That definitely should have. It actually should have increased the signal, but it actually was exactly the same, leading me to believe that something is horrifically wrong. I am very likely to spend some time this weekend working on this. I will check the schedule of the Twitch channel to see if it's available. Okay, so Hanny, to answer your question, Andreas tells me that the inputs for those objects should have been 1 times 10 to the 6th. Meaning that when we subtract the background from that, it should be smaller. But if I do not do a background calculation at all, it should be exactly 1.10 or 1 times 10 to the 6th. So we're just literally trying to back all the way up to literally just counting electrons inside of the aperture without subtracting the background from it at this point. So you know the deal. When you're debugging, you simplify the problem as much as you can. You create a model that's as simple as possible, but will still give you like reasonable results that can help you down the path towards what we're working on. Let's see. So let's try this again, and I'm getting tired of moving everything over to this monitor for you guys. You've all seen it plenty of times. Now we just got to wait for the output, for the analysis to finish, the output. I'm also concerned that this is taking so long on this image with just 4 objects. God, it's me again. It's waiting on input. Pay attention. Alright, now I'm waiting. But the fact remains, I'm still waiting too long. This is 4 objects. This analysis should go very quickly. There's my output. No, it is literally exactly the same. Oh boy. Well, now this is stressing me out. Let's see here. Okay, that's still going to be 0 because background is 0. Let's fix where our background is set. 0. Where the hell is it? Oh, it's up here. No, it's not. Why can I not remember? Oh, you know what? I just realized I'm using the same variable name. Oh, you rascal, you dirty rascal. This isn't helpful to me right now, so let's get it back. Whoops. Let's see. We're going to do a sanity check, friends. And we're going to set breakpoints there. Might as well set one here too. So we can see what's going on as that background, because I'm starting to wonder if I'm not coming back with something 0 in the first place, which is going to mean that the background is not getting subtracted from the objects, which could... highly doubt it. The 40% signal is a result of the background not being subtracted, but it's definitely something to look at, right? We've got to okay, desktop fits images, test noiseless, 6 standard deviations, and give it all its input that it wants. 1 0. Alright, let's see what our debugging console says. Yeah. Man, this is a lot of information here. I can't imagine why there's an X variable at that value right now. But, so our size is 6. That's good. That's good. Clipped mode is around the clipped mode is around 100.5 intensity. That's good. Where is and then the size of the array. Okay, this could be problematic because that doesn't make sense. 30,000 pixels. Y'all help me out. Does that seem reasonable? Let's do some circle math here. Where's my console? So the outer annulus radius is 160 pixels. So if the radius is 160, what is the volume? So the volume, or not volume, area, since we're working with a 2D object. Area of circle is 2 pi r, is that right? Area of circle. We're going to ask Google because I don't trust my memory. Area of circle, pi r squared. See? It's a good thing we didn't trust my memory. So pi times radius was what? 164 pixels, essentially. And that will be squared. Okay, so that's 84,000 pixels. And then we have to subtract the inner circle, 84k pix. And then the inner circle was 131 pixels squared. And that is going to be 54k, which leaves literally 30k. Okay, so what we have going on here is we have a 100 being divided by 30,000, giving me a very minuscule background. And I don't think I'm going to need to get clarification from my scientists when I get into the office this afternoon on that. But that's a very interesting piece of information. It's given me some insight as to what might be going on, and that's what we're here to do, right? So good stuff. No, Hanny, I haven't written any unit tests yet. I kind of just debug by eye and ear and feel for now. However, before we submit this as a full release, we'll obviously be running it through heavy testing, including having our volunteers play with it and try to break it. So yeah, no unit tests written yet, but I'll be working probably early next year with my scientists. We've got the AGU conference in December that we're going to present. And once we get back from that, I'm sure we'll be ramping up. I'm pretty sure I'm going to get another teammate or somebody, too, to help me get this code going, and we'll kind of go from there. But it's all up in the air I just know between now and AGU, I've got to get this figured out. So speaking of getting this figured out, I'm rolling up on 45 minutes, and like I say, I got to get to the office to wish my friend and co-worker a fond farewell to his new post-graduation big boy job. He's graduating from student developer to graduate developer, and we want to have a cocktail with him and wish him farewell. So I've got to get ready to bounce out of here. It's been fun hanging with you guys as usual. Don't forget to follow. Oh, and like I say, if I get some work done this weekend and this channel's not available, I will probably be streaming from my own. If you guys aren't following me on Twitter, please do. I always tweet when I'm going live on my own channel. And I used to tweet when I go live on this, but it's just kind of on a calendar, and I got away from that. But I will get back to it. The Twitter handle is CQX_Joe. If y'all want to check that out, give me a follow, and I'll keep you posted on when I'm doing cool stuff. That will become very active when I hit Washington, D.C. for the AGU conference as well. I actually created that account for the AAS conference that we went to in January in Washington, D.C. And you can scroll all the way back to that and see lots of cool stuff from the Space and Flight Museum, the African American History Museum. We went to the several of the government buildings. We went to the White House. We went to I forget the name of the buildings, but we actually went and hung out with one of our favorite senators, Senator Kristen Gillibrand from California. She's an ally to science and an ally to ladies and minorities in the sciences. So that's what we went to talk to her about. We wanted to see if we could count on her to keep fighting for us. And I believe we got a confirmation from her because she is a seriously badass female. But anyway, got to get to work, guys. Oh, before I go, I want to show you one thing. Check this out, my BRB screen. What do you think? Simple yet elegant, right? All right, guys. I'm out. Have a good one. Thanks for hanging out.